This conference will now be recorded.
In the last class, I have explained layout managers. Already I explained there are 5 layout managers. They are flow layout, border layout, grid layout, card layout, and grid bag layout. So the first 4 layout managers I explained in the last class with example programs. As we know, all these are predefined classes and all are available in which package? Java.awt package. So last class I have explained flow layout, border layout, grid layout, and card layout. In today's class, I will explain grid bag layout with one example program. See, already explained in the last class what is the default layout for all the layout for all the AWT controls is flow layout, and this is the default layout flow layout, and in the flow layout center is the default alignment. So if you take all the previous AWT programs, you will see all the AWT controls are arranged in the center part of the applet window because of flow layout is the default layout and the alignment is the center alignment. So already explained flow layout with example program. Please do the programs, then only you can understand the concept. First see the output, based on the output, see the program, then execute the program. Next border layout I explained with program. Grid layout also explained. Next layout is card layout I explained. But in card layout, last class I have explained only one program. So with respect to this structure, I have explained in the last class. Card layout. What is this structure? So always see the structure from right to left. Here, 2 AWT controls are added to this panel, and these 2 AWT controls are added to this panel. Panel is nothing but a card in card layout. And what is panel? Now I will explain the difference between panel and applet. Panel is a rectangular box with no status bar and title bar. But whereas in applet window, we have both title bar and status bar. That is the main difference between panel and applet window. So tell me, what is the difference between panel and window is? Only one difference. Panel is a rectangular box with no title bar and status bar. But applet, for applet window, we have both status bar and title bar. That is the only difference between panel and applet. Next, here we will see the structure from right to left. Here I have taken 2 checkboxes and I have added to the panel 1. And here I have taken 2 more checkboxes and I have added to panel 2. So each panel is nothing but a card. In card layout, we will discuss the concept about with respect to cards. Like already last class I explained, bunch of cards or deck of cards, 13 cards. 13 cards we are treating them as one single bunch. Means those cards cannot be independent. That's why what we have to do in card layout is take the cards as you like, 13 cards or 5 cards or 2 cards. Each card is nothing but a panel. Panel is a rectangular box with no title bar and status bar. So these 2 panels are added to the main panel. Then only we can treat this as a bunch or a deck of cards. So here how many panels? 2 panels. 2 panels means 2 cards. So after creating 2 panels, we have to add these 2 panels into the main panel. This is must. Then only these 2 cards will be considered as deck of cards. Okay, this is the main concept in card layout. So this program already explained in the last class. I have given one more program on card layout because card layout is very important to understand the concept. Remaining are easy only. Now what is the second concept I have taken in card layout is implement the following structure using card layout. Here what I have taken is, see, I have taken 5 panels. Each panel is nothing but a card. So I have taken 5 cards or panels. After that I have to add these 5 panels to the main panel. And for each panel we have to add AWT controls now. Here for first panel I have added label. Label is an AWT control. In the previous program I have added 2 checkboxes to panel. But here I have added one label to panel. Like that you can add buttons, text fields, any AWT control can be added to panel, like applet window. Panel is nothing but a rectangular box with no title bar and no status bar. So like that I have created five panels, and I have added AWT controls like label to each panel, and after that all these 5 panels are added to the main panel. So how do we write the program is same as the previous program. So take this structure and you try to write on your own. Otherwise you can see my program and execute the program. Here already explained. Now next last you have to use. I have used mouse events. You know mouse events means implements mouse. The implements mouse listener means mouse listener consists of 5 abstract methods. So I have given the implementation to the 5 abstract methods of the mouse listener. So inside that I have written the code. Some are null implementation, some I have written. See, I have used next, I have used last, I have used show. Like that I have written the concepts. What is next? Already explained. The first card to be visible is the first card. Which card is added first to the main card? That will be visible always. Means first card is added, no? That's why first card is visible by default. Next, after that, whenever you click this first card, by using this next method, you will see the second card. Means second card will be displayed on the applet window. Like that, when the second card appears on the applet window, again if you use the next method, you will see the third card. Like that, whenever third card appears on the applet window, if you click previous, for third card, previous card is second card now. So for the third card, previous card is second card and next card is third card. Fourth card. For third card, previous card is second card and next card is fourth card. Like that we can use last, next, previous. Last means it will show you the last card. What is the last card? I have added fifth card. So if you use mouse centered method, you can see the last card, that is fifth card as the output. Next, show means each card is given one name. So with respect to that name, we can see that particular card. If you use show, then here I have written the card name is third. Each card must be given name. With respect to that card name only, we can access the particular card randomly. How do we access the particular card randomly? Is using show method. That's why each card is given one name. With respect to that name only, we can access that particular card using show method. Like that, you practice last, next, show, previous, all these methods. First card is always the default. By default, it is visible. So understand the second program of card layout. Next, in today's class, the main layout is grid bag layout. Now we will see the output first. After that, we will see the program. What is grid bag layout is? This is easy only. So what is the drawback of grid layout is? Already explained grid layout, no? So what is the drawback of grid layout is? In grid layout, the components are arranged row by row using the concept of rows and columns, like matrix form. So this is the grid layout. So in grid layout, all the components are arranged. First line has to be filled. After that, second line. After that, third line. So row by row, the components are arranged from left to right. That is the concept of grid layout. Each grid is nothing but one AWT component. It can be button or label like that. So what is the drawback is all the components are arranged in term with respect to rows and columns, like matrix. But suppose if you want to arrange all these grids as you like, you can't arrange with respect to grid layout. Suppose if I want to arrange the grids as I like, then I should go for grid bag layout. Like I think, do you remember that one jagged arrays I explained? When I explained arrays, jagged arrays. Jagged arrays means we can take any number of rows and any number of columns as per our requirement. No need of writing in a particular order in jagged arrays. Like that here in grid bag layout also. See, this is my structure. I want to arrange the AWT components in this particular order. With grid layout, it is not possible to arrange the components in this particular order. So what I have to do is I should go for grid bag layout for this particular structure. So here what is the structure? In the first row I have kept two components, in the second row one component, in the third row one component. With grid bag layout it is not possible. If you take for the same program with grid layout, the components are arranged like this: red, then yellow, then blue, then green. All are arranged in the first row. If the first row is full, then only the components are arranged in the second row. Like that, row-wise arrangement is possible in case of grid layout. But here I want this structure. How do I get this structure? Is using grid bag layout. So grid bag layout is a predefined class. See, now I will explain this program. Grid bag layout is a predefined class. It has only one constructor. Next, after that, here constraints are there in grid bag layout. Understand this one. So what are the two constraints I have considered for this program is relative and remainder. I will explain the meanings of these two constraints. In addition to these two constraints, some more constraints are there. If you want to learn in depth about the constraints of grid bag layout, please check this complete reference book. In the complete reference book, you can find all the constraints. Now I will explain relative and remainder. What is relative meaning is, see, suppose if I take the red button, after red button I have to put one more button yellow, no? So in this case, for red button you should give relative. Relative means after that button we can arrange one more component. Relative means, suppose if you give relative constraint to this button red, means after red button you can add one more component. Next, after yellow no need to add any component, no? That's why for yellow you should give remainder. Remainder means after this component, if you don't want to add any other component, then give remainder for this button. So for red button give relative constraint, and for yellow button give, what is the constraint? Remainder. Next, after that, two rows completed. So not two rows, one row completed with two buttons. After yellow, I don't want to put any other button. Next, shall I go to the next row? That is blue. So how do I put blue button is, next for yellow I have given remainder, no? Means no need to put any other button after yellow button. Next, after that I have to get blue. So for blue, what constraint should we give? After blue, here there is no component, no? That's why for blue button give remainder. Next, we will go to the third button. For green also we should give remainder, because after green there is no other button. After blue also there is no other button. So for yellow, blue and green we should give the constraint remainder. For red only we should give relative. Understand the meaning? Once you understand the meaning, program is 1 minute. So for red button you should give relative constraint, and for yellow, blue and green buttons we should give remainder, because there are no other buttons which are after these three buttons. That's why give remainder. But here one more important concept is, see, for yellow I have given a remainder, no? For yellow I have given remainder constraint. Means whatever constraint we have given for the previous button, that is carried out to the next button. So after yellow we have to take blue, no? So what is the constraint for yellow? Relative. So that is carried out to blue also. Because for blue also I want only remainder, no? That's why no need to set any constraint separately to blue, because the remainder constraint of yellow button is carried out to this blue button. Anyway, we need to only remainder, no, for blue. Next, after that, for green also no need to set the remainder constraint, because blue is having remainder constraint that is carried out to the green button. That's why only set constraints for yellow, red and yellow with respect to this structure. See how to set the constraints relative and remainder is based on your structure. So for in this structure, for red I will set relative, and for yellow I will set remainder. Once you set remainder constraint for yellow button, that constraint remainder constraint is carried to both blue and green. That's why in this structure only set the relative constraint to red and the remainder constraint to yellow. That's it. You'll get this structure. So how do I set? I will explain. See, everything is same. Here, using set constraints method, we should set the constraint either relative or remainder, and other constraints are also there. I have not written. So if you want more in depth about those constraints, you please refer complete reference. So here, void set constraints method. In set constraints method, this method is there in which layout manager? Grid layout. Not grid layout, grid bag layout. Grid bag layout is a predefined class. It has one constructor log and one method set constraints. This method is available in grid bag layout. Using the grid bag layout class object, we should access this method set constraints. Here it is taking two parameters. One is whatever AWT component you want to take, write the first parameter as AWT component, and the second is constraints. Constraints are relative and remainder I am explaining. No? Now how do we use set constraint method? Set constraints method we see. So first three import statements same. Next, see here public class extends applet, because here I am not using event handling. That's why no need to write implements listener. After that, take 4 buttons, because this is my structure now. This is my structure. I want to get as output of this one. That's why please see this structure and use the corresponding constraints. And here 4 buttons are there with labels red, yellow, blue, and green. That's why I need to create 4 buttons with the 4 labels. That is the first concept. So here before init method, I am creating reference variables for button class. After that, see these are the button objects with the corresponding labels. Next, after that, last class I explained now how do we use the layout manager. See, inside init method, you have to add one more step. Already init method consists of 3 steps now in AWT controls programs. But in layout managers programs, init method consists of 4 steps. First one is creation of objects. Second is that adding listeners to the AWT components. Third, adding the AWT components to the applet window. These are the 3 steps which are common to all the AWT controls programs except mouse events and key events. Already explained in depth. But in layout managers programs, there should be 4 steps in init method. The same 3 steps, and in addition to those 3 steps, we have to add one more step that is extra only in layout managers. For all layout managers, you have to add 4th step inside the init method. What is that 4th step is you have to create the object for the corresponding layout manager. Is it the object of grid bag layout? Yes. So grid bag layout gbag is equal to new grid bag layout. This is the object of grid bag layout. After that, in the previous 4 layout managers, I have added this grid bag layout object to set layout to applet window using set layout method. So first statement and third statement are common to the remaining 4 layout managers. But only for grid bag layout, we have to add this one more statement. What is that statement is because we have to add constraints, no? That's right. One more statement we should add only for grid bag layout is this is the statement. What is this statement? Grid bag constraints. It is a predefined class. We will create object for grid bag constraints class. That is grid bag constraints GBC is equal to new grid bag constraints. So only for grid bag layout, these are the 3 steps we should follow for any program on grid bag layout. For the above 4 layout managers, this second statement is not required. Only create the object for the particular class, particular layout manager. After that, add that object to set layout. Send that object as parameter to the set layout method, which will be added our grid bag layout to the applet window. Set layout is a predefined method in applet class. Okay. After that, so I have created objects for 2 classes. One is grid bag layout and the other one is grid bag constraints. After that, how do I set the constraint to the buttons? This is the next step you should remember. So GBC means grid bag constraints object. So GBC is the object for grid bag constraints. So GBC dot grid width is equal to grid back constraints is a predefined class. In that, relative and remainder are the constraints which are constants and which are static variables. So static variables are accessed outside the class using class name. Now that's why grid back constraints dot relative. Relative is the constraint. So this line is must to set a constraint to a particular AWT component. Here that AWT component is button. So GBC dot grid width is equal to, write like this. After that, how do I set that constraint to button 1? Button 1 is red now. For button 1 red, with label red, I have to set relative constraint now. How do I set this? This is the syntax. So gbag means grid bag layout, not grid bag constraints. So grid bag layout object dot set constraint is a method of grid bag layout. So gbag dot set constraints of, for button we are adding this relative constraint. That's why B1 comma GBC. GBC dot grid width is assigned this value, and that we are adding to button 1. Like that, for each and every button, based on your requirement, you have to add whether relative or remainder. So this is the syntax. Similarly, for next button, I have to add remainder now. How do I add? Same concept. GBC dot grid width is equal to dot remainder, and button B, for button B2, I am adding this GBC. Like that, for each and every button, first you have to use the corresponding constraint and add that constraint to that particular button. But here, to get that structure, only for buttons B1 and B2, we have to add relative and remainder. For the remaining buttons, no need to add no. This remainder is carried out to button B3 and B4. So whatever constraint which is there for the previous button B2, that is remainder no, that will be carried out to B3 and B4 unless you set the constraint for B3 and B4. Anyway, here we need for B3 and B4 also remainder only no, according to that structure. That's why no need to set any constraint for B3 and B4. Already previously we set for B2 remainder, that will be carried for B3 and B4. That's it. So after executing that program with applet viewer, you will get this structure. Similarly, I have given 2 more structures. You practice the grid bag layout for this structure. Now you can see this structure. What is this red? After red, no, there is no button now. That's why for red set remainder. For red button set remainder. And after that, for yellow button, you have to set relative. Because after yellow button, we are adding one more button blue now. That's why for yellow button, you set relative, and for red button, you set which one? This one, remainder. Next, for blue button also, you have to set here. For blue button, set remainder. So for red button relative, for red button remainder, for yellow button relative, for blue button remainder. Again, for green button also remainder now. But for green button, no need to set separately. Why? Because it inherits from the previous button blue. Already I have set remainder constraint to blue, no? That is carried out to this green. That's why here only for 3 buttons we have to set the constraints out of 4 buttons. What are the constraints we have to set? For red button remainder, for yellow button relative, for blue button remainder. That's it. Next, write the program on your own. Next we will see. I want to arrange the components in this order. So what is this order? So here for red button, set remainder. Once you set the remainder constraint for red button, it will be carried to the next buttons now. For all the 4 buttons here, we have to set the constraint remainder now. But once you set the constraint remainder for red button, that will be carried to the remaining 3 buttons. That's why out of 4 buttons here, only for red button set the constraint remainder. That's it. Because that remainder constraint is carried out to the remaining 3 buttons. Because anyway, these 3 buttons also need remainder constraint. That's why out of 4 buttons, set only remainder constraint for the red button. That's it. That's why based on your structure, see which constraints we have to set. So here I have explained remainder and relative constraints in grid pack layout. Like that, you practice the other constraints also. So with this, grid pack layout is completed. Now the next topic is last topic of this 50 unit is swings. Now I will explain half part of swings, and in the next class we will complete swings. So next class is the last class. Next we will see swings. So now we will see what is the difference between applets and swings, or AWT controls and swings. So only one difference, the major difference is, see here, read this statement. AWT controls like button, text field, text area. I have explained 9 AWT controls now. All those AWT controls are developed using different languages like C, C++, Java. That's why they are not platform independent. But whereas swing components are developed using only Java. That's why all the swing components are named with J button, J text field. Means for all the swing components, J is prefixed. We should prefix with J. If previously label is there now J label. Button is there. AWT component is button. So the corresponding swing component is J button. Next text field, J text field. Like that, all the swing components are prefixed with J. Because all the swing components are developed using only one language, that is Java. That's why J is prefixed for all the swing components. That's why AWT controls are not platform independent, while swing components are platform independent. Platform independent means no, Java is a platform independent. That's why all the swing components are platform independent. So here A is missed. So AWT components are platform independent. Differences between Java AWT and Java swings. So platform dependent, platform independent, heavyweight, lightweight. Like that, Java AWT components are not following model view control. It is one type of architecture, but swing components follow MVC, means model view control. See the differences, you can easily understand. Next, now we will see, already explained AWT hierarchy, like that here this is the swing hierarchy. If you take this AWT, all the AWT components are the subclasses of this component class. So component class is the superclass of all the AWT controls. But the swing components, all the swing components are subclasses of J component class, and J component is a subclass of container, and container is a subclass of component, and component is a subclass of object. So all the swing components are subclasses of which class? J component class. And all the AWT components are subclasses of component class. Understand the difference between AWT components and swing components. Next, this is the difference. See what I am saying. All the swing components are subclasses of J component, but except 2 classes. Here arrows are there. So except 2 swing components. What are the exceptions? J frame and J dialog are not subclasses of J component. See, all these yellow color components are swing components. So what we can understand from this swing, this hierarchy is, all the swing components are subclasses of J component class except J frame and J dialog. And this is the hierarchy. And one more important point is, we can see this one, J label, J button, J scroll bar, J radio button, like this, J text field, J text area. All these are swing components. So all the swing components must be prefixed with J. Next, like applet, applet is a predefined class, no? In applets, like that, J applet is a predefined class which is used to write the swing programs. J applet instead of applet. We will see the difference between applet and J applet. See, already this structure, object, next component, next container, next panel, next applet. So applet is the subclass of the panel. Panel is a subclass of container, like this. Now we will see what is the difference between applet and J applet. Again, J-applet is a subclass of applet. See, the relation between applet and J-applet is J-applet is a subclass of applet. So you need to remember this hierarchy. So after that, in Swing programs, we will use only J-applet in place of applet. And now there we have used a component. No, here you have to use J component. J component already explained. J component is the superclass or base class of all Swing components except top level containers. Okay, now this. But see, J frame and J dialog, these two are not the subclasses of J component. Already explained. And now we will see J component. This is J component constructor. And next we will see the Swing programs. Swing programs are also same as AWT programs, only small differences. Now I will explain only those differences. Otherwise, the rest of the remaining programs same as AWT components programs. Now we will see what are the differences. In the AWT programs, we have written import java.awt.star, not AWT, applet.star. So in AWT components programs, import java.applet.star. In place of that, here we should write import javax.swing.star. Javax means you can imagine like extension. So import javax.swing.star in place of import java.applet.star. That is the first difference. Only I will explain the differences. These red colored ones are the differences. Otherwise, program concept, everything is same. No need to explain that. See, here also import statements are there. 3 import statements are there, like applet programs. And this is applet tag is same. And here there we have used applet, no, extends applet. But here you have to use extends JApplet. And JApplet is the subclass of applet. So all the methods, all the 5 lifecycle methods of applet class are inherited to JApplet, which are in turn inherited to our class. Means inside Swing demo also we can use all the 5 methods of applet class, because JApplet is here it is following multi-level inheritance. That is applet, then JApplet, then under that Swing demo. That's why for Swing demo class, all the 5 methods of applet class are inherited. Next JApplet. See, implement action listener now. So all the listeners are same as like AWT programs here also. Action listener, item listener, all the listeners are same. Here there is no J concept, and the listeners and listener interfaces, methods, everything is same. That's why no need to explain here separately. Only I will explain the extra points. Next, first I will show you the output for this program. With respect to that output, I will explain the program. Here I have taken one label, that is J label. Enter a number is a label, that is J label. After that, these two are text fields. 5 and 120 are text fields. And this is a button. Button is J button. And this is J label. And these two text fields are J text field. Only as J. The rest of the concept is same as the AWT components. Now factorial is a button with label factorial. Whenever you click this button, some action is generated. To listen that event, event listeners are important. Listeners are there. Same concepts. Okay. Now I will explain. So what are the Swing components we should take to get this output? Tell me. One J label, next 2 J text fields, and 1 J button with label factorial. So these are the Swing components. Same concept. So here, see, I have created globally the 1 button, 1 label, and 2 text fields. So, but J button, J label, J text field. This is the one more difference. After that, in init method is same, but inside the init method you have to use this one. For all the Swing programs, inside the init method, these 2 lines are important. Here I will explain one more difference between the applet programs and Swing programs is, for applet programs, all the AWT components are added directly to the applet window. But here in Swing programs, all the Swing components are added to the container. That is one more difference between applet programs and Swing programs. That's why whenever you write Swing programs, all the Swing components must be added to the to the container. Okay, that's why these two lines are extra important things for all the Swing programs. Now I will explain these two programs in depth. Now what are the two statements? Container C is equal to get content pane. Already explained, no, container is already explained in container is a, what is that one? Runtime is a singleton class in garbage collection, no? Already explained in singleton classes like runtime. Runtime is a predefined class which is a singleton class. What is the meaning of singleton classes? For singleton classes, we cannot create objects with new operator. That's why how do we create objects for singleton classes is by using the factory methods like get runtime. I explained when I explained that garbage collection. Like that, container is a singleton class. That's why container class object cannot be created with new operator. So how do I create the container class object is by using the factory method get content pane. So get content pane is a factory method which is used to create the object for the singleton class container. Understand the meaning of this. You cannot write container C is equal to new container because this is a singleton class. For singleton classes, we cannot create objects with new operator. So factory methods are used for creating objects for singleton classes. That's why this is the object creation for container class. After that, all the AWT all the Swing components are added to the container. That's why C dot set layout managers we should use in Swings. Why? Because there in AWT components, unless you add any layout manager to the AWT program, what is the default layout? It is a flow layout, no? But in Swing programs, there is no default concept. The layout manager should be added explicitly to the container. So how do I set the layout to the container is C dot, already I have created object for container class now. So C dot set layout of new flow layout. If you see the applet programs, there is no C dot. Directly set layout. Set layout means we are adding the layout to the direct applet window. But here we are adding the flow layout to the container. So the major difference between AWT programs and Swing programs is for Swing programs we will take applet window. But in Swing programs we have to take the container. All the AWT, all the Swing components and layout managers should be added to the container, not to the applet window. That's why first you have to create container class object. After that I have to add the layout manager as well as the Swing components to the container. In AWT programs there is no C dot. Directly add, and here also directly set layout. So here there is no default layout concept. That's why you need to set the any one layout out of 5 layouts explicitly to your container. That's why I have used C dot set layout of new flow layout, because flow layout is the easiest one now. In flow layout, all the Swing components will be arranged line by line, and center is the default one. Alignment is the default one. So these are the important points. Otherwise, you can remaining rest of the program same. So what are the 4 points you should remember is, I will repeat once again for this program. If you understand for this program, for the next programs, no need to explain once again. So this is first statement. Import javax.swing.star. Next second is japplet. Next create the Swing. All these are called Swing components, not AWT components. All the Swing components are prefixed with J. So create the Swing components reference variables. After that, create the Swing components objects like same as AWT. Next, after that, the important points are here all the Swing components are added to the container, not to the applet window. That's why you have to create a container class object. For that container, we have to set the layout as flow layout. Here you can take any one layout out of 5 layouts. But in this program, I have taken flow layout. In the next programs, I have used border layout, grid layout like that. Based on your requirement, you have to set the flow layout. And the layout must be set explicitly. There is no default concept. Compulsory one layout must be set to the container explicitly. That is one more difference. Next, all the swing components are added to the container using add method. That's it. After that, you know this concept, listeners and everything concept is same only. No need to explain separately. Once I will show. Here JApplet implements action listener. No, in action listener we have one method, that is action performed. So inside action performed method you should write the logic. Already this logic I explained in AWT components. See, public void action performed. Inside action performed method, the parameter is action event AE. This logic is for finding the factorial of a number. After finding the factorial of a number, you should display that value in the second text field. In the first text field, you give the one number. In the second text field, you will get the answer when you click the factorial button. That is the output. So first program is completed. Next remaining programs I will explain only the concept. Next second is radio button. So if there is no radio button concept, there is no radio button class directly in case of AWT components. No, always compare applet programs or AWT components and swing components. Compare and study. Finally, I will give you one table. Now what I explained in AWT components label. What is the corresponding component in swings is J label. Label J label. Next button J button. Next text field J text field. Text area J text area. Like that, for some components names are same, but only in swing components you must prefix with J. But not always. But here in radio, but in AWT components there is no concept of radio. There is no class like radio button. No. But in swing components, radio button is there directly available. What is that class is J radio button. See, J radio button is a predefined class. But this class is not available directly in AWT components. What is the corresponding class for radio button is checkbox group. Next here checkbox also same. Checkbox in AWT components is equal to J checkbox in swing components. So checkbox J checkbox. But their checkbox group is for radio button. But here radio button, J radio button class is directly available. So checkbox group in AWT components is same as J radio button in swing components. You remember, otherwise concept is same. So J radio button. Here add this one. First I will show you the output. After that I will explain the program. See here, I have taken 3 radio buttons using J radio button class. Okay, here J radio button class is directly available. So that's why you are getting, see this row circles. Circle is represented for radio button now. But there in checkbox groups, you will get square only. Because we are taking different checkboxes and we are adding to one group. But here the J radio button class is directly there. That's why you will get circles. Circle indicates radio button. No? Now, how many radio buttons are there? Here 3 radio buttons. What are the 3 radio buttons? So this is first radio J radio button with label A, second radio button with label B, third one is labeled with C. So I have taken 3 radio buttons. But here also the concept is that after taking 3 radio buttons, all the 3 radio buttons must be added to one group. Like a checkbox group, no? For checkbox group class, I am adding checkboxes now in case of AWT components to get radio button concept. But here, even though J radio button is available in swings, but here also we must group them. Out of this group, only one can be selected. So group concept is same. You can't write independently like this. All these 3 J radio buttons must be added to one group. That is important concept. And next after that I have taken label. Whatever radio button you selected, that will be printed here. See. Suppose if you select A, you selected A. If you select B, you selected B. You selected this one is the label and that is the output. Next. So all the 3 radio buttons will be added to one group now. What is that group is? Same, this is to create the radio button class object, and one method is add method. Next, after that, after creating the radio buttons, you have to add all the radio buttons to button group class. This is important. There we have created checkboxes and add checkboxes to checkbox group. No? Like that, we have here we have to create radio buttons. After creating 3 radio buttons, we have to add the 3 radio buttons to the button group. We have to group them. That is must. Like card layout also. No? In card layout also, I have taken 13 cards, but after taking 13 cards, I have to add that 13 cards to the main card now. Okay. In card layout also, we have to use grouping concept. In radio button also, we have to use group concept. So here, what is the corresponding class is button group. So I will explain this one. Same concept, import java.swing. Here J applied same. So buttons I am using now. That's why action listener. Next, take these two same. Container C is equal to this one. See, these two are same for all the swings programs. Inside the init method, we have to create container class object. For the container class object, use the set layout of whatever layout you want to use in your program. You have to write that particular layout. So these two statements are must for all the swings programs. Remember. Next, after that, after creating 3 radio buttons, I have created. See, how do I create 3 radio buttons? See, J radio button is a predefined class in swings now. So J radio button B1 is equal to new J radio button of what is the label of the radio button is A. Within the double quotes we have to do. This is the constructor of the radio button with string as the parameter. That's why you put in double quotes. Otherwise you will get error. So 3 radio buttons I have created with labels A, B, C. After that I have to add all these 3 radio buttons to one group now. What is that group is button group. So button group BG is equal to new button group. This is important. So create the button group class object. After that, for that button group class object, add your 3 buttons. Means, what does it mean? I am grouping all the 3 buttons. So I am adding all the 3 buttons to one group, that is BG. Means all these 3 buttons are under one group. So in that group, I can select one radio button. Only one radio button can be selected if you use button group class only. Otherwise, they are treated as independent. Group compulsory button group. So all the 3 radio buttons are added to say the same button group BG. After that, these listeners, everything is same. See, listeners are same. And for the 3 buttons, I am adding listeners. After that, see, this is one more important point I explained. No? All the 3 radio buttons must be added to the container, not to the applet window. In swings programs, all the swing components must be added to the containers, not to the applet window. So everything is safe. I have created one label now. So I have created one label. That label is added to the container. So all the swing components are to be added to the container. Next. So whenever you click this is one group now. So first I have created 3 radio buttons. I am adding to one group. Now all these 3 are under one group. Under this group, you can select any one radio button. So here, how do I display that which radio button you have selected? That is the output. So how do I use this? Already I have taken this action listener now. Implements action listener. So this concept is same as AWT. So implements action listener means inside action listener one method is there, that is action performed. So I have implemented that action performed method. Inside that action performed method, I have written the logic to get this selected radio button label. How do I write? Label is J1 now. So J1 label, I have taken one label, that is J1. J1 dot set text of you selected. Here you will get this text plus AE dot get action command. Whenever you click this radio button, using get action command, you will get the label as output. So get action command will give you the label of the radio button. You selected will be displayed here. This is the program using radio button. Explain J radio button with example means you can write. Next, this is also easy. J combo box. J combo box is treated like choice in applets. So in applets, in AWT controls, it is choice. Choice means already explained choice and list in AWT components. No? In choice, first items are added. After adding the items to the choice, only one item should be selected from the choice. But Here, what is the corresponding this component in Sphinx is J combo box. So J combo box is same as choice in applets. So J combo box in Sphinx is same as choice in applets. Already you know choice concept, no? So no need to explain separately. I will explain only the major important points. So here is J combo box is treated like choice. So you have to add items to the choice, no? Like that, you have to add items to the J combo box. Either using one by one, we can add items, or you can create one-dimensional array, and we can set that one. We can send that one-dimensional array as parameter to the J combo box. Next methods, add item one by one. If you want to add, use add item. Next, get selected item means which item is selected from that choice. You can write. See, program these three import statements: applet tag, then J applet, then first I will show you the output. See, here I have added for choice 3 items. What are the 3 items? Vanilla, chocolate, and strawberry. So after adding the 3 items to the choice, that is the J combo box, I have to select only one item now out of the 3 items. Here I have selected that strawberry. After selecting that item, that item is displayed in the text field. That is the program. So this is the text field you have to take. Inside the text field, whatever item you have selected from the J combo box, that selected item will be displayed in the text field. You can easily understand this program. So how do I see everything is safe? No need to explain this one. See, I have created one which one J combo box object and one text field. 2 are enough, no? One J combo box means choice and one text field. Inside the text field, I am displaying the selected item from the J combo box. Next, see, these 2 are same, no? Container C dot set layout, and for J combo box, add 3 items one by one using add item method, or you can use the constructor which takes one-dimensional array as parameter. Next, C dot add up. For container, I am adding all the swing components C. For text field also, I am adding to the container C, not to the applet window. Next, the listener also we have to add to the this one. Everything is same. Next, here I have taken implement item listener, no? That's right. In item listener, I have one method item state changed. Inside that, I have written tf dot text means for this text field, I am setting the text as ie dot get item. ie dot get item means whenever you click this J combo box choice or this is selected, no? That's why using ie dot get item, you can take the selected item and that will be set to the text field using set text method of text field. That's why strawberry is set to the text field. That's it. Last one, with this I will stop. The fourth one I will explain. Next, J tabbed pair. What is J tabbed pair means? First I will show you the output. This is also very easy. Understand the concept. J tabbed pair. It is a swing component. Okay. All the swing components are there in Java dot. Next, see which package? Next, shall we see this one? These are the tabs. Understand this. Once you understand this output program is 1 minute. So these are the tabs. So this is the entire. This is applet window. What is this applet window? Applet window must have. This is the title bar. This is the title bar. This is a status bar. It is a rectangular window with the title bar and status bar. And already explained panel means these are panels. See, this rectangular box is there, no? See, understand this one. This rectangular box is called panel. So for panels, there are no status bar and title bars. It is only simple rectangular window. You can understand in this program. See, this blue line is there, no? This is called panel. Panel does not have status bar and title bar. But this window is called. It is also a rectangular window. But here this applet window has both the title bar and status bar. That is the difference between applet window and the panel. So what I have taken, how many tabs I have added? 3 tabs. What are the tabs names? Cities, colors and flavors. So for each cities is one tab, no? For each tab I will add the this one cities. This is cities tab, no? So I have added 4 cities to the cities tab with panel concept. First inside the panel, this is panel blue one. This inside the panel I have put four buttons with labels New York, London, Hong Kong and Tokyo. All these 4 buttons are added to the, what is this one? Panel. After that, this panel is added to the cities. Understand carefully. So cities is a tab. After that, I have to add 4 cities to the cities tab. How do I add the 4 cities to the cities tab? Is I have to take 4 buttons with 4 cities labels. After that, all these 4 buttons must be added to one panel. Otherwise, these 4 are independent now. But I am grouping them. I should group them. How do I group all the 4 cities? Is using panel. So for one panel, I have added all these 4 buttons. After that, this panel will be added to the cities tab. So remember the terminology. Next, after that, next colors is one more tab. Next, inside that color, again colors is this tab. For that colors tab, I have to add one panel, and this panel consists of again 3 check boxes. See, these are 3 check boxes. Previously, I have taken for cities radio buttons. Here, any component you can take. 3 check boxes I have taken, and all the 3 check boxes are added to one panel. This blue line is panel. All the 3 check boxes are added to panel, and this panel is added to the colors tab. Same concept. Next, flavors. Flavors is another tab. Another third tab is flavors. For flavors, I have added one choice. Choice means J combo box, no? So same vanilla, strawberry, same choice. That is radio button, J radio button, not radio button. J combo box, I have added 2 flavors. So any swing component can be added to these tabs. But I have to add choice now. How do I add the choice? Means directly I can add that. But first we have to put this choice in the panel. After that only that panel can be added to the flavors. Same concept. So now this is the output. Now I will show how to add. For one tab I will explain. For the remaining you can study on your own. Easy only. See, understand the flow. So J tabbed pen is the swing component which is used for adding tabs to the applet window. Till this is like this. There is no such concept in AWT components or applets, because we cannot add tabs to applet window in applets. There is no AWT component, no. So this is the new component which is there in the strings. That is J tabbed pane, which is used to add tabs to the applet window. So J tabbed pane is a predefined class. It has one constructor and it has a method is there. No, what is that method? Add tab of. You have to use first one is string, second one is the component. This is the add tab method. How do we add the tabs to the applet window? Is using the add tab method of J tabbed pane. So next here I have written the procedure. You first understand that procedure and apply the same procedure in the program. You can understand easily. I will explain about one tab. Similarly, the remaining 2 tabs. Here see same 2 import statements. Here event handling is not required. That's why no need to write implements any listener. See, not for all programs event handling is required. Only for based on your requirement, which programs need event handling. For those programs only apply event handling. Otherwise, no need to apply. For this program, no need of event handling. Only tabs now. Whenever you click that tab, the states will be. Whenever you click the cities tab, the cities will be displayed. Whenever you click that one, what is that one? Flavors. The flavors choice is displayed. Like that only we are displaying. No need of doing any action. So no event is generated. That's why no need of event handling. See, important is only this I will explain. With this we can stop. No. Now container C get content pane C dot set. These two are the same. No. Now only concentrate on these two statements. If you understand these two statements, enough. So how do I create tabs or how do I add the tabs to the applet window? Is what? Using tabbed pane, no? J tabbed pane class, no? That's why first you need to create J tabbed pane class object. So how do I create J tabbed pane? JTP is equal to new J tabbed pane. This is the constructor of the J tabbed pane class. So create the object using first create the J tabbed pane class object. After that, for that object, use add the tabs. So here how many tabs I have used? Cities. And next what is the other tab? Colors and flavors. So using add tab method, add cities, next colors and flavors to the what? J tabbed pane. So first create J tabbed pane class object. After that for J tabbed pane class object, JTP, you have to add 3 tabs like cities, colors and flavors. So first component is string. String name is as you like. You can take any string name for that tab. So that's why the constructor we will see. Add tab of string. This is the tab name and this is the component. Which component you are adding. Now I will explain it. So JTP dot add tab of cities is my tab name. And for that tab, we have to add panel. No? Now understand the link. So see, for the tab directly we are not adding the 4 cities. First 4 cities must be added to the panel. Then add that panel to the cities tab. That is the concept. That's right. For cities, this is new cities panel I have written. Means first I have to create panel. I have to create panel. For that panel only I have to add 4 cities. Directly 4 cities cannot be added to the cities tab. For the cities tab, first you need to add the panel. For that panel only we should add the 4 cities. So how do I add the panel to the cities is using here. For if we have to see, we have to take one user defined class. What is that user defined class? Is class cities panel extends J panel. So already explained. No, if suppose if you take the same case, means this class is nothing but it is defining panel. Like that I can explain this one. Class my applet extends applet. Means to write applet programs or to create applet. So how do we write applet? Class my applet extends applet means that is applet. Next, how do we identify whether it is a thread or not? Is class my thread extends thread or class my thread implements runnable means that is a thread. No. Next, class applet class my applet extends applet means my applet is nothing but applet. Like that, how do we know whether it is a panel or not? Is any class which extends J panel is nothing but panel. So how do we create a panel? Is using class cities panel extends J panel means this is nothing but a panel. This class is behaving a panel. For panel we can add any panel is a rectangular box. No. For panel we can add any number of AWT components. So understand again I am repeating the statement. Class cities panel extends J panel indicates that this class is behaving a panel. Panel is a rectangular box. For that rectangular box we can add any number of stringed components. So once you understand this is behaving panel. So once you understand this one, I am creating the object of cities panel is the user defined class. No, I am considering the object of cities panel class as the second parameter of the add tab method. So cities is the name of the tab, and for that cities I have to add one panel. What is that panel? Is cities panel. Now that is cities. This is nothing but cities panel class object. Next, whenever this statement getting executed, the tab name is given as cities, and immediately from this new cities panel, the control goes to cities panel constructor. Already you know this one. Whenever you create an object, compulsory one constructor must be invoked. No? Here this is also new means object creation. No? Whenever this object is created, compulsory using this constructor, it will go to the cities panel constructor. So from this, it will go to the, from this, it will go to this line, that is cities panel constructor. So in this, inside the cities panel constructor, what I have written, I have created I have created 4 cities with buttons labels like New York, London, Hong Kong, and Tokyo. After that, I am adding to the panel. This panel is what? Cities panel. So for that panel, directly I am adding button B1, B2, B3. So what does it mean? This, understand this class carefully. This class is nothing but a panel. Why it is a panel is, this class extends J panel. Means this class is treating like a panel. Panel is a rectangular box, and the AWS swing components can be added to the panel. How do I add the swing components to the panel? Is using this panel constructor, cities panel constructor. Inside the cities panel constructor, I have added 4 cities to the add B1 means New York button is added to panel. See, this is, there is no dot no here, means all these 4 buttons are added to the panel. And what is that panel is? This is behaving like panel. So here this class is nothing but we are creating a panel and we are adding 4 cities to that panel. Okay, how we can identify it is a panel, whether it is a panel or not is any class name can be anything. Any class which extends J panel can be treated as a panel. Once you take one panel, for that panel we can add any number of swing components. Here I have added 4 J buttons to the panel. That one. After that, this is what new cities panel. No, so with this from this statement, what we can understand is using add tab method. The name of the tab is cities, and using the panel concept. First, for the panel, we are adding 4 cities. And after that, this panel is added to this tab cities. So this panel is added to the cities. And for this panel, so with the constructor of cities panel, we are adding 4 buttons. Like that, the remaining you can understand for understand flavor. So with this program is completed. You can understand this remaining easy only. Same concept. Next, whenever you click the cities, these will be displayed. Now you can understand first panel. For panel, we are adding 4 buttons, and that panel is added to the cities tab. So like that, whenever you click the particular tab, if you click the colors tab, 3 checkboxes, because 3 checkboxes are added to the colors tab using panel concept. Next, for flavors, one choice. Choice means J combo box is added to the flavors using panel. Compulsory we must take one panel. For that panel, we have to add the swing components, and that panel is added to the tab. For the tab directly we can see, remember this point. For the tab directly we can add the swing component. So in between tab and swing component there is panel. So what is the concept is, first create a tab with some name. After that, create one panel. For that panel, first add swing component, whatever swing components you want to add. After adding the swing components to the panel, add that panel to the tab. So this is for J tabbed pane. So with this J tabbed pane completed.